Well, hello and welcome back. We started at a random time today, and I guess we're going to go for a random length of time. I don't know exactly how long it's going to take me, but I'm going to set a goal. Um, it's going to be at least 10 minutes, and uh, we're going to have the complete FFT explanation as simple as possible for everybody. Um, Okay, so join in computer scientists, join in geeks, nerds, join in regular people. We're going to play around with Python for a minute and then we're going to dive into C. All right. So you are probably wondering what FFT is. At least I am definitely wondering what is FFT. Um, and so that's why I'm teaching you guys what it is because I don't really know what it is. And I would love to see your comments um, roasting me or, you know, calling me less than smart, calling me less than intelligent, because I am certainly a student. And so what you have here now is the main function. This is Python. We're going to start off with Python and then we're going to move to uh, C. So, um, and I'm going to assume that you guys know the language. Uh, but if you don't, just please write in the comment if I've said something that you don't understand or that you might found me to have been wrong. Okay, so what I want to do is make it plain what FFT is. So I've created this string right here on this doc string, and what I'm going to do is essentially define this main function. And in this main function, what I want to first do is, well, I have pass here, so I don't really need to pass because now I'm going to define it. Well, let's just see how it runs real quick, just so you guys can get a feel for how this is going to look. All right, so it ran. It's perfectly fine. Did nothing. It passed. There was no error. Okay. So in this main program, what I want to do is, this is really designed to teach me um, about FFT. So we write code sometimes just to learn, okay? Or at least I write code sometimes just to learn. And the first thing I'm going to do is print out the doc as my main function. Okay? And so when it runs, we get this big jumble of strings right here. Or this big string. So I don't necessarily like that. So what I'm going to do is I'll get rid of the print here. I want to do something else with doc. I want to split doc. Yeah, I want to split doc. And so that's going to be a list. So let's just call this list uh, the steps. All right. And so since it's a list, we can just run a loop. We can say for step in steps. And now we can print. We can use our little print function. Okay. Um, and we want to print each step. And then I guess just for, you know what, just as a test, I want to see what happens if you print two strings and if you give two strings to a print function. Because I forgot what happens. Okay, so we got our little bitty main function here written. Okay, we only need, let's just do 70. Yeah, we don't need much. I mean, I'll do 77 lines. Why not? Anyway, we've got our main function. Okay, so now what we're going to do is run it. So far, our main function is not even using the Cooley Tukey fast Fourier transform. We're just trying to understand it. Okay, so let's run it. Okay, so I split them it's split in the wrong place. It's split in the wrong place, right? I didn't really look at my string. I split it at the commas. It's supposed to be split at the semicolon. So I go in and I change that. Okay, so now this gives us more of a separation of ideas. The FFT is a math tool that finds hidden patterns in signals. It's like identifying ingredients in a recipe. Okay. All right, so I don't necessarily like that. So what I want to do is I want to enforce a kind of input. This is part of the reason why we use Python to prototype. Because prototyping is easier in Python. And we're going to move to C in just a moment with this fast Fourier transform. We've got it written in Python, but the problem is we need to understand in the age of AI and age of AI agents and coding and all of this, we need systems architects, we need systems level thinkers, we need people who actually understand, how things connect and who are able to put it into application. And so that's what I'm here to do. Um, and if nothing more than make a message to myself for the future. Um, I'm I'm doing this here. So, and this is the Zero to Hero course, right? We're starting off as a zero, meaning we know nothing, we have nothing, except for the very bare minimum, which is a cell phone, um, and we might have a laptop, and we might have a little bit of money, but we're gonna create all of this live though, okay? Because on our roadmap, the first thing we need to create as systems architects, we need to create a task tracker. But we're using the fast Fourier transform to get us just in the computer scientist um, frame of mind and thinking, right? With a very heavy subject, I would say, for the average person. But FFT or the fast Fourier transform, which I'm going to overwhelm you guys with shorts. Well, I'm not going to overwhelm you. My cycle of posting shorts is going to be maybe like one a day at around 9 o'clock Eastern Standard Time. Uh, but I'm going to kind of like try to disperse it evenly, the other content, so that it doesn't necessarily overwhelm you guys. But anyway, the FFT is a math tool that finds hidden patterns in signals. So any signal, um, you know, a signal is the basis of senses, right? Our senses. Our senses pretty much process signals. Okay, so an FFT is a math tool that can find hidden patterns that are in signals. So an FFT is kind of like your brain's way of understanding information that's been presented to it. All right. The use of the word signal, I think, is triggering, and it's because in a way many people they don't understand what a signal is. At least me, I don't understand what a signal is. you know, but that's something that we're gonna absolutely understand by the end of this. Okay. So it's like identifying ingredients in a recipe by tasting the finished dish. So FFT is like identifying ingredients in a recipe by tasting the finished dish. So we start with a messy signal that changes over time. So let me think about that. It's like identifying ingredients in a recipe by tasting the finished dish. So I taste your sweet potato pie, and I can tell if you use cinnamon and nutmeg, or if you added sugar or something else. So a hidden pattern in a signal is like a hidden ingredient in a dish. Okay? So the secret sauce. FFT is a map tool to help us find secret sauces. If y'all are tuning in, please like and subscribe, share the channel. Uh, so we want to start with a messy signal that changes over time. I don't understand that, but let's keep on going. We want to see what repeating frequencies are hiding inside it. We want to see what repeating frequencies are hiding inside it. Okay. So first we reorder our data using binary mirror patterns. So binary mirror patterns, that's a thing that that's a thing that we're gonna have to understand. Binary mirror patterns. That's a key phrase there. We reorder our data using binary mirror patterns. So essentially, we're taking our data and we're mirroring it on the bit level. All right, so this is like shuffling cards in a special way to make the next steps faster. So I know I went on a tangent before about how bitwise arithmetic is faster than, I guess, standard arithmetic, or that every arithmetic I guess function or operation in a language like say Python, underneath it is a bitwise process to make it faster. Anyhow, This is like shuffling cards in a special way to make the next steps faster. Then we begin the butterfly operations in multiple rounds. Okay, so we shuffle the cards in a special way, and then we begin the butterfly operations in multiple rounds. In round one, we pair up neighboring data points. So the butterfly operations are something that we're going to have to understand. But the butterfly operations, in a way, it's kind of like if it's in one order, like 1, 2, 3, 4, 5, 6, going down on one side, the butterfly operation is to make it go 6, 5, 4, 3, 2, 1. So 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2, 1. That's the visualization that I'm having in my mind. I don't know if you guys are following me, but let me know. Uh, in in round one, we pair up neighboring data points. Okay. Each pair does a special dance of adding and subtracting. They all also multiply by a twiddle factor that acts like a rotation. So the twiddle factor, so we got butterfly operations, we got twiddle factors, we got binary mirror patterns, right? A lot of stuff that we won't understand until we just kind of like put some time on it, but anyhow, frequencies as well. They also multiply by a twiddle factor that acts like a rotation, okay? This mixing process combines and separates frequencies. It combines and separates frequencies. We repeat the process with larger groups each time. Okay. After all rounds, messy time data becomes clear frequency information. Hmm. Interesting. I don't know how. It's still magical to me how this works, but look, we're gonna work through it. So the results show us exactly what frequencies are present and how strong each one is. So this lets us analyze sounds, images, and many other types of data. Okay. So anyhow, maybe enough talk. So we've got that. We don't ever need that rundown again. All right. So I'm gonna delete the input there. Um, and now in the main function, I guess I want to, demonstrate the fast Fourier transform. And so we got to understand the data type. Uh, the data type. So if we want to do a FFT on X, what is X? It seems like X could be a string, or X could be an array. All right, so N is equal to the length of X. So if I put something in there with the length of, I just need to put anything there with the length, I guess. We're gonna try it out. So anyway, um, let's. How about this then? We'll say Q equals input Q equals input. Um, I guess the input should be something along the lines of um, I'll say t- I don't know. I don't know. What input do I want? Something with the length, right? I don't know. I'll just say any data. We want any data, right? Any data. We just want any data. So that's what the input is going to be. Any data whatsoever. And then I guess with that Q, we can run an FFT on the Q. Uh, yeah, we can run an FFT on the Q. Uh, and I guess we need to make sure that it's a list. I'm not sure. I'm just going to go with that because I know it needs to be something like an array. So, so after we do that, we're going to go ahead and just reassign that to Q so that the value we can get. So I could say for now we'll just do a print. Um, well, I don't even know what X is. I'm going to say type Q. I would just want to know the type of what Q is going to be. But, I don't need to know the type. I can read this code and figure out what the type is going to be. So X is X. So X is whatever it is. But X gets reassigned. You know what? My question is, can it be an integer? I don't know if X could be an integer. But X seems like it would be some sort of it seems like it had to be some sort of an array of at least two. Ah, that's the big catch. It has to be of at least two things. An array of at least two things. So right now I'm gonna test it out and see what happens if I do it with one. But I don't even need to know the type. But I'm just gonna do a quick experiment. So here we go. So the data, I'm gonna give the number 7, and it returns 7. Okay. So what if we do 77? Ah, math is not defined, huh? How is math not defined? Jesus. Did I not import math? You know what? I don't even remember when I wrote this. I probably didn't even write this. Okay, so it says type error, unsupported operand types for string and string. Okay. Okay, so they're not supposed to be strings, so it has to be integers. So in my function here, I have to specifically transform Q into, I guess, an integer. You know what? This is going to be my last experiment, then we're going to get to our regularly scheduled program. Happy birthday to I Show Speed. Ugh, we can't do that. If we turn it to an integer, it has no length. So then we have to change FFT. Uh, or let me see. Well, no, all we got to do is uh, hmm. So if somebody gives me a number, then I have to uh, I think that should work. Oh, it's not iterable. You know what? We got to do it like this then. So we got to do a list. First, we just say Q equals Q list. I mean Q equals list Q, and then we can say yeah. I think we can say that Ni for I in Q. I think that should work. Okay, it worked. All right, so seven sep. So ah, the fast Fourier transform. So 99 is actually, it has a hidden pattern of 18 in it, whatever that means. So let me just try this real quick. Let me make this to an infinite loop, or more or less an infinite loop. Uh, so I'll say uh, I'll say while actually when I first define Q, I could say while bool Q. Okay, so while bool Q return true. Actually, I'm gonna say if bool Q return true, and then I'm gonna say else turn false. So that's gonna make our main able to have a value. All right, so we can go down here to this main and now say um, let's say let's call it flow. Look, don't blame me for the names, y'all. We'll call it flow. Uh, and we'll say while flow or while yeah. Actually, I don't even know if this is gonna work. I think I could do that though. Right? So while flow, call main again. Or actually flow is equal to main. So it gives a chance to, I guess, be false. So, like for instance, right there. Since I didn't enter anything, I just pressed it. Since it was false, it never ran. But if I want to go back to my, let's try 11. Oh, you know what? It didn't work. Okay, so okay. Oh, you know what? It probably printed, but this crap, I have to get rid of this crap here. So, so I want that to happen, but not all the time. So I'll put it here. Ah, okay. So the hidden pattern of 11 is 2. So what about 13? 4 and -2. I'm sure you guys are ready to go and jump into C or C++. But once again, happy birthday to ISO Speed. He's 21 years old. So let's just do 21. Ah, 3 and 1. Interesting. Who knows what the secret meaning of this could be? But this is just um, the fast Fourier transform. Okay. So I think what would be really interesting is to add one other element of this. But you know what? Let's see. How long have we gone on? 38 minutes. Well, I guess we may as well pull out an hour or so. I really only wanted to go for 10 minutes, but we could do an hour. In fact, let's try to break our system by putting in 3. Ah, see, it's out of range. This is really interesting. So, think what I want to add in this will be the modulus of the doc. So I'll take this domain and edit. I will put, well, with it, I'll take the modulus you know what? I'll create a count. I'll create a I'll call it a call count. The call count. I'll equal it to 0. Wait a minute. Huh. I know what I have to do. I have to give main an argument. I'll call it CC. And then I'll start CC off as 0. And then I'll add CC to the main flow. And I guess every time it flows, we'll say yep, we'll say CC plus equals 1. And then with that, we could, inside of main, we could print the steps dynamically with just entering in CC. Interesting. 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 All right, so today we might not actually get into the sea because I'm just too overwhelmed and too fascinated with this particular fast Fourier transform. I think I'm gonna finish up this hour and then I'm gonna come back on for my standard 10 minutes and we're gonna get into the sea. All right, so I'm trying to see the pattern here. Huh. Interesting. Well, damn. Hidden patterns and signals. Triple O one. Okay. It's got a crazy imaginary number. Two insane imaginary numbers that come along with that. I don't even want to look at the bigger stuff with that. So what about 20? What about 05? Interesting. What about 0100? What about 60? Interesting. Fast Fourier transform. Okay, so we see that main can take data that's manually inputted. So we want to take it to our next level where in main we want to actually uh, give it some input. So we're going to say Q is equal to none, just as a standard one. And that might raise an error, but I'll fix it if it does. And so what we'll do, come down here and say is uh, if Q is equal to none, okay, so now I just need some data to use this Cooley-Tukey Fourier transform on. Any data whatsoever. So we may as well use the data that we have, which is the doc. So right now, all right, so I'll say if the flow is true. Um, what I need to say here is I have a question. The question is, I have a question, and the question is equal to um, hmm, question is equal to hmm. All right, so what I wanted to do is I guess take the first two characters. I guess it's about how I want to transform this. That's what it boils down to. How do I really want to transform this? And I'm just gonna, on the fly, well, you know what? I'll be back.